All right, in part C, we want to algebraically find the particular solution to the differential equation given the initial condition of negative 1 comma 2. So we factor out a 6 minus y, divide through by 6 minus y. I'm sorry, factor out an x squared and divide through by 6 minus y. Then we're going to integrate both sides with respect to x so that the dx's on the left cancel out. So we have integral of 1 over 6 minus y dy is equal to integral x squared dx. On the left side, I do have a function composition there, and I'm going to use a simple u substitution, but dy is simply going to be negative du. And so I'm going to replace 6 minus y with u and dy with negative du. And so I have negative integral du over u is equal to integral x squared dx. Integrating, I get negative natural log of absolute value of 6 minus y is equal to x cubed over 3 plus c. Multiplying through by negative 1, I have natural log of 6 minus y, absolute value of 6 minus y is equal to negative x cubed over 3 plus c. Now I could plug in at this point, but I'm going to continue. I'm going to exponentiate both sides, and that will leave me absolute value of 6 minus y on the left and e to the c times e to the negative x cubed over 3 on the right. Getting rid of the absolute value bars would then leave me 6 minus y is equal to plus or minus e to the c times e to the negative x cubed over 3. And finally, if I were to solve for positive y, I would get y is equal to, actually I think at this point, because I don't want to move the plus or minus around, I'm just going to plug in my x is negative 1, y is equal to 2 at this point. And when I do that, I'm going to come up with 4 is equal to plus or minus e to the c times e to the negative 1/3. Now, e to the negative 1/3 is really 1 over e to the 1/3. And what I'd like to get rid of that to solve for the plus or minus e to the c. So again, I think there are more than one ways of going about doing this, but what I'm going to do is, since that is 1 over e to the 1/3, I'm going to multiply that by e to the 1/3 on both sides. And I'll have that plus or minus e to the c is equal to 4 times e to the 1/3. So I can go back and now substitute that in, and I get 6 minus y is equal to 4 e to the 1/3 times e to the negative x cubed over 3. And solving for y, I'd get y is equal to 6 minus 4 e to the 1/3 e to the negative x cubed over 3. Now since I'm multiplying two numbers with the same base, I can add those exponents. And so I would get, and actually at this point you may have spotted this, but I did make a mistake up here. When I had negative 1 to the third power, that should have come out negative 1, and then I still have a negative outside of that. So that should have come out as positive 1, which would mean that I would have to multiply then that by negative e to the negative 1/3. So I'm going to adjust those now, so that my plus or minus e to the c is actually 4 e to the negative 1/3. I fixed that in the following two lines. Now I'm ready to simplify the e to the negative 1/3 times e to the negative x cubed over 3, and that would be y is equal to 6 minus 4 times e to the negative quantity 1 plus x cubed over 3. And that's the final answer. Now there's a big question as to where you should stop when you're integrating and plug in your initial value. And the answer is that anywhere after you've done the initial integration, it's okay to do that. And you really need to practice these. There's another, I think that the solution that the College Board provides has a slightly different approach to it, and you can study both ways and see which way is comfortable for you. But they're both okay and should end up with the same answer in the end. So that is our answer for part C, and we're done with this problem.